Improper integrals. Before starting exercise 5.3, we must know some definitions, important definitions of improper integral, because in exercise 5.3, we need to integrate these improper integrals and we have to tell whether these integrals converge or not. For that purpose, we must know that what exactly improper integral means. They have given here the definition of improper integrals. In some of the definitions given here on page number 183, definition 5.13, and then definition 5.14 and definition 5.15. You must know all these definitions in order to start exercise 5.3, because these are the main concepts that we will use in solving the exercise 5.3. If we come to this definition, and we have the integral in our questions, we have the integral of this type, a to infinity. Basically this infinity, improper integrals, in improper integrals this limit of integration, whether this limit of integration is undefined or at any point of the limit the function becomes undefined, the integrand becomes undefined, then we call it as improper integral. And how we will just solve these improper integrals? If the question is of this type, like you have the upper limit as the undefined limit, then you will just break it into the limit, and limit t approaches to that undefined term, and integral a to t. Basically you are replacing your infinity term with t, and here you will write it like t approaches to infinity and the rest of the things will remain as it is. You will integrate this portion, and after getting the answer of this integral portion, you will just apply the limit at the end. If the answer is defined, then you will say like this integral is converging, and after putting the value of the limit, if it becomes undefined, then you will say like it diverges. Now come on definition 5.14, and the same continuation of 5.13. If we have this kind of integral in our questions, like the lower limit is undefined, then you will break it into the limit, t approaches to that lower limit, integral, and now you have replaced it with the limit, so you will write here t. Limit t approaches to negative infinity, and in place of negative infinity you will write t. So this is another kind how you are going to interpret your question. Another kind is, if you have a question of this type, you have the limits of integration from negative infinity to positive infinity, then you will break your integral into two parts. How you will break it? You will minus infinity to 0, like this, minus infinity to 0 and 0 to positive infinity, and then you will just integrate it. How you will integrate it? Now here in opening this integral you will use this definition, and in opening this integral you will use this definition that is given in the start, and then you will just integrate it. If both the answers are defined, then you will say like your this given integral converges. If any of them diverges, then you cannot say like it converges, you will say like this diverges. Now come on definition 5.14. If you have a function of this kind, like there is no undefined term here, but on putting the limit, upper limit, like for example you have 2 here, the number, and on putting the 2 into this function, the function becomes undefined, then you will again break it into the limit, and you will write it like t approaches to b minus. If the function becomes undefined on the upper limit, then you will write b minus and replace it with t, and then integrate it. And if the function becomes undefined at the lower limit, then you will write it like t approaches to a plus and replace that lower limit with t, and then integrate, and then observe whether the answer is defined or not. Now another definition is, for example you have an integral of this kind, you have some values here, a number here. Now neither a nor b gives you undefined function, but in between these two values there exists some that kind of value that is basically making that function undefined. that will be the breaking point, and you will break your integral into two integrals, and that point that is making your integral undefined, let's suppose that point is C, you will break it like A to C plus C to B. So this is another method how you will open your integrals. So you have to keep in your mind all these methods while solving this 5.3, because these are the starting definitions you have to apply while opening it, and after applying it you can just different integrate it normally, as I showed you in chapter 4 how you can integrate the functions. So let's start exercise 5.3. Question number 1. 0 to infinity e raised to power minus x dx. It will be equals to, now upper limit is infinity, you will just write it like limit t approaches to infinity 0 to, now replace this infinity with t, e raised to power minus x dx. Now you will integrate it as it is, like I showed you how to integrate the functions in chapter number 4. E raised to power minus x 0 to t, this will be integrated as e raised to power minus x over minus 1, and the limits of integration are from 0 to t. This will become limit t approaches to infinity, this thing. Now you can write it like negative e raised to power minus x 0 to t. This will become limit t approaches to infinity. Now put the upper limit minus e raised to power minus t, then formula minus, and this minus will give you plus, and this will become e raised to power minus 0. This will become limit t approaches to infinity, and this term, this will become minus e raised to power minus t. You can also write it like minus 1 over e raised to power t, and this term is 1. Now apply this limit here, you will get minus 1 over e raised to power infinity plus 1. So this will give you minus 1 over infinity, that will give you 0 plus 1. So here you will get 1. So you will say like given integral converges. So in this way you can solve your rest of the questions. Now question number 2, solve this improper integral from 0 to infinity e raised to power minus x sine of x dx. You will write it like limit t approaches to infinity and replace that infinity with t. It will become e raised to power minus x sine of x dx. Now you need to integrate it. I am taking this as first function and this as second function, and integration by parts will give you limit t approaches to infinity. I am writing this brackets, so because I have the limit here, that will be applied at the end on the answer. Now first function as it is into integration of second function minus integral derivative of first function. Derivative of first function will give me e raised to power minus x minus, and integration of second is minus cos of x here dx, and here on the whole the limits of integration. Now limit t approaches to infinity, I will apply the limit of integration at the end. This will become minus e raised to power minus x cos of x, and the limits of integration are from 0 to t. Minus minus, this will give you plus. So this term will become equals to plus this minus minus plus, and this minus again will give you minus 0 to t